Okay, guys, I hope you're all fine. Let's start on matrices. In this case, our focus is on computing determinants of matrices of order 3 by 3 or higher. That's right. So please, I'm going to discuss 3 by 3, but you must try to see how you can adopt this approach to 4 by 4, 5 by 5, 100 by 100 until you cannot do it manually, but maybe you need to program it on a computer and do it nicely. All together? Okay, let's start then this way. Yeah, before maybe we really engage on this thing. Can you see on the board there? Can you see? Okay. I think this is a kind of page which is in your study guide. I think what you can see there is what you've assessed on, depending on this concerning this matrices. Like for example, we must do all the basic calculation on matrices, evaluate determinants, which we're doing today, determine the inverse of matrix using Gauss-Jordan method. In this case, Gauss-Jordan, they're referring to that reduced row echelon form. Remember, they're going upwards, going downwards. That's right. So they use that term also using Gauss-Jordan for 5 matrices. Then differentiate between the consistent and the inconsistent system of equations. We are going to see that when we solve the equations. We've solved some questions, but we haven't really encountered a problem where it gives us an inconsistent system. We're going to discuss that. Then the rest, I think it's just applying of matrices in whichever situation you are dealing with. Is that right? Okay. So let's start this way. And then, as far as calculating matrices of determinants of matrices of 3 or 3 by 3, let's start with this matrix A. Please, guys, you can copy these things as I was doing it. Try to train your hand also to write the right symbols and so all those things. I think that's very important. A equals to 4. I'm reading this in columns 4, 6, 3. And then we've got minus 1, 2, 3. And then we've got 3, minus 1, and 2. And then we close it. Please, guys, those are square brackets. Those are square brackets. All right, like we said before, we can either use this notation, det, for determinant of A. And if that was not beautiful for you, you can use this one. I don't think there's anything more beautiful than this. All clear? And they will read it as determinant of A. Both of these symbols, we read them as determinant of A. But we've already seen a determinant of A for a 2 by 2 matrix. So you just need to understand that that kind of a calculation, it's actually kind of a function. In this case, you are having a function here defined on square matrices of order n. In this case, n can be 2. We've seen that. N can be 3. That's what we're going to discuss now. And that must give you 2. It's a function which acts from that. That's the domain. Square matrices, order n, and the value there is going to give you what? Real numbers in this case. Okay. So then we can say now here, determinant, in whichever form you want to do it there. Determinant is a function there. Yeah, that dot there, I'm just saying that it's going to pick something there and put it there, then assign it a number. Altogether. But that something there is a matrix of order n. Altogether. Okay. So now, the determinant is a function from square matrices to real numbers. You decide on what order of matrices you're dealing with. Now we're dealing with 3 by 3. We write here determinant of A equals to a straight line. Please, guys, make sure that you see the difference between this line and that line there. Because the notation must talk to the person who is reading, and they talk to the person who is reading correctly. Altogether. So that is a straight line. 4, 6, 3. I hope everybody now is aware that if you don't write a straight line, you know what is going to happen. You know, if you put this there, then there you put a bracket, you know what's going to happen. Yeah, okay. No, that's fine. That's a 3 and the 2 there. Then that's that. I'll start with one method which I think is the simplest one. Recall that these entries there, we say they are along the principal diagonal. Are we together? Now these entries here, -1 and -1, they are along a parallel to a principal diagonal. So applies these two. So applies a line which runs through this element this way is also parallel to the principal diagonal. But unfortunately, these ones, they've got 2, this one has got 1. So what I'm going to do now, check what I'm going to do. I'm going to go on along the principal diagonal. I'm going to take 4 multiplied by 2 multiplied by 2. That's what we're going to do. Plus, then I'm going to go parallel to the principal diagonal. Then I realize, I've got 2. I need 3. I'm not going to go back this way. I'm going to go back this way. You understand what I'm saying there? That line is telling you that these 2 are going to go with that. As what? As a product like these 3. So then I'm going to have -1. Please never leave this thing written this way. That's illegal. All together. So -1 times -1 times 3. Are we there so far? All of us? Okay. So I think now we can guess what's going to happen, isn't it? You take this parallel. I find there's only one element there. Then I turn around. I come there. All together. Then what I'm going to pick there? I'm going to pick 3 times 3 times 6. This is the sum of products along the principal diagonal and its parallels. I hope I'm making myself clear. Am I? I say that is the sum of the product of the entries along the principal diagonal and its parallels. And must be careful how you check those parallels. All together. Okay. Then what's going to follow next here? I'm going to subtract and open a bracket there. What I'm going to subtract now? I'm going to move now along the secondary diagonal. Along the secondary diagonal. So what I'm going to have there, that bracket is going to start there. I'm going to have 3 times 2 times 3. Unfortunately, I cannot write there plus, I'll write it there, plus. Next thing, I'll take this parallel to the secondary diagonal and then turn around and pick one element that side. I'm going to have there 3 by -1 and by what? By 4. Are you fine with that? Huh? If you are fine with that, there might be something wrong with you. You can't leave this thing like this because it looks like a minus. I've just told you there that you can't leave those things like that. Sides after that. Put a bracket there. Altogether. Okay. So that's that. Then the next thing is plus What's that? I'll take this 2 parallel to that first one, then I go around and pick the other 2 elements that side. What are the 2 elements that side? 2 times 6 times minus 1. Are you fine with that? What's wrong? Brackets there. All together. Then that. Please be strict with that. Don't do signs like that plus following a minus like that without putting one of them in brackets, please. So then what follows there is just a simple calculation which we must do. This is 16. While somebody is switching on the calculator, I'm telling the answer. That is 16. And this is 3. Whilst you are pressing your buttons, I'm telling you that this is 3. And this is 9 and times 6, that's 54. Yeah. It's a plus, no? Yeah, plus 54. Then we put that there, minus, this is 9, 18, 12, minus 12, plus, minus 12, minus 12. Looks like you're going to get minus 6. And there, come again, 73. And then 60, 67. This is a minus 6. Is it not going to minus, minus, then plus, plus? 79, is it? Yeah, 70. Do you agree? Let's double check that. 79. All together? Okay. Just double check the calculation. Is it fine? Okay. So, from our previous discussion, we can already conclude that this is a matrix which would have n inverse. All together? All together? Okay. Because it's different from 0. There's no need to write different from 0. I'm just writing because I made a comment on this thing of the existence of an inverse. Is that right? Okay. Otherwise, the determinant can be 0, can be negative, positive, it doesn't matter. It doesn't need to be a whole number, also it can be a fraction, and all those things. How together, guys? Are you happy with this one? Huh? Sure. Okay, that's nice. Right, let's see another slightly different approach, but very similar. Right, we start here with exactly the same matrix. This is not a different method, just a slightly different approach of exactly the same thing. So don't take it very, very different. But some people might like it, but I'm not going to advertise it, whether this is better or that is better. Myself, I'll just give it this thing for you to choose yourself which one you are comfortable with. So what do you do here? You get your matrix exactly as it is. Oh, sorry. There's something wrong there, isn't it? Yes. Okay. You see, the teacher also can make mistakes. So which means students must be more careful. Oh, it's a misprint. Yeah, it's a misprint. The teacher does not make mistake. Makes a misprint. Okay. Now, let's go. That's 4, 6, 3, minus 1, 2, 3. That's row. That's a column. 3, minus 1, 2. Then we do something like this. Dotted line there. Just like that. Dotted line. Then you repeat the first rows. 1, 2. Now you take 4 here. 6. I'm saying the first rows. What do you mean first? Columns. You're making the same mistake I'm making. I've infected you with my diseases, all of them. Minus 1, 2, 3, and that. I know some people are going to say this is beautiful. but anyway, the beauty is in the eyes of the beholder. So then let's do it this way. We do draw a line here, a nice one for those ones. Then another line there for those two. Another line there. I hope you excuse me because these things cannot be perfect lines, but I think you can see what I'm trying to target with my line, isn't it? Yeah. Right. The only thing though why they don't match very well is because the lining of the on the screen there is not very good. All right. So once I've got that, I do exactly what I was doing before. If you check, you're doing exactly what I was doing before. What is it? 2 times 4 times 2 times 2. 4 times 2 times 2 plus 3. So guys, if you leave this bracket here, you have a plus minus there. That's going to look very clumsy. Altogether. Yeah. Then it's 3, 6, 3. We close that in brackets. So we say minus. Then what we have here? 3, 2, 3. 3, 2, 3 plus. I think that's still 79. If it changes, then it means we never had these things before. Altogether. Yeah, you confirming that is 79. It's exactly the same things you have had before. This is just a layout which might be maybe easier to some people and not really beautiful for some other people. So you can just choose which one you want. So there is the thing. Done. Huh? Beautiful. Beautiful. Now, let's do something else now. I actually want to introduce, which I think I did talk about this thing. I want to introduce what we call here minors. Minor. I'm going to name the minors this way. I'm going to call a minor A11. Simple. A minor in this case is a determinant of a 2 by 2 kind of matrix. Okay. So what do I do when I talk of 1, 1? I reduce this matrix by dropping row 1. Maybe let me draw a line there. I'll drop row 1 and I drop column 1. What is left there, I capture it as a determinant of a 2 by 2. And that's a simple number 4 minus 4 plus 3, which is a 7, is it? Okay. I'm going to be quick now because I'm dealing with people who know these things. Then I go 1, 2. Look how beautiful is that. Then whatever is not dropped, I capture the determinant is 6. And that's a 12 plus what? That's 15, eh? Yeah. So 12 plus 3. Then I go A 1, 3. Do you see that? Looks beautiful, huh? Okay. What are we left with there? 6. We're quickly getting these numbers because we're supposed now everybody knows how to calculate 10 into 2 by 20. Yeah. So we just get them. 18 minus 6. What's that? 12. A2. Is that right? Okay. Then you get there. What are we getting here? Minus 1. Then minus 2. Minus 9. Minus 11. Then A 2, 2. What do we have there? The corners, isn't it? Right. That is what? Again? Minus 1. Okay. Then A 2, 3. What do we left with? Now let's continue. A 3 1 minus 5. Are you sure? Oh, it's 1 minus mine is 6, okay? Minus 5, isn't it? A 3 2. Am I fine there? Then what is that? Minus 4 minus 18. What's that? Minus 22. What is it? Come again? 18. 14. I think what is important now for us is this setup here. Altogether. Well, the question is, how are we going to use this setup to calculate the inverse? Not the inverse, the determinant. Okay, these are minors. Sorry, I wrote minor there. These are minors, right? Now, let me tell you something. I can, like this, I can make a matrix using this A11, A12. You can see that I can make a 3 by 3 matrix with these numbers. That's right. Everyone can see that. So what I can do now to calculate the determinant of this matrix, I can either move along the row of that matrix or move along the column of that matrix. And when I'm saying along a column, I'm saying any column, I'll get exactly the same thing. Altogether, I'll give you a chance to test that. But together now, let's remember one thing which we said before. There is this function here, which I said we're going to call it a sine function. A sine at row that, column that, which we defined as minus 1 to the power r plus c. Call that a sine function. Not the sine k, the light function, no. The sine plus or minus function. Altogether. So this function, what it does, it just gives plus or minus. Altogether. Okay. So now this is what we're going to do now. We want to calculate the determinant along this row, which means in the matrix there, I'm moving along that row. Altogether. So this is what we're going to do. We're going to say determinant of A equals to, if we start there, which means this is 1 1 altogether, 1 plus 1, isn't it? So we're going to get pick 4 and have sine function there, 1 plus 1. Then we multiply by the minor. The minor there is 7. Altogether. Altogether. Okay. So when we've got this product of minor and this sine function here, we call that cofactor. This here. This is called the cofactor. Not without 4, these two. That's called the cofactor. So here what I'm doing, I'm using cofactors and the minors to calculate determinant. Altogether, guys. This is a method of using cofactors and minors to calculate a determinant. Then let's go. Then what do we do? Plus, we move along that row, we'll have minus 1. And they have the sine function. I'm writing it explicit today. This is the first time, so everybody must see it very, very clearly. Tomorrow you can cut your shortcuts, but you must cut shortcuts only when you start understanding. See what I was doing there? I was trying to write the minor as it is there. Altogether. But I can just take the number there. What is the number there? 15, is it? Otherwise, if you're just calculating, you would write the minor there. You don't mind. So it's not a problem. So that becomes 15. Then plus, where are we now? We're here, isn't it? So put 3 there. The sine function there. It's a value at row number 1 plus column 3. Then we took the minor, which is there 12. I think it's clear to you, all of you, that a minor is actually a determinant of something, isn't it? Okay. So now, but this is now going to be determinant of the matrix where these minus are coming from. Altogether. Okay. So now let's see here. Here we're going to have positive, and then we're going to have minus 28. Am I making sense there? And then there, we've got a minus sign here. And here we've got the minus 1 to the power 3. The sign will come out as what? It's minus, isn't it? Then we've got a minus and minus, that becomes positive. Then we've got plus 15. Am I all right? Okay. Then when you come here, the sign here, according to the sign function here, is going to be minus 1 to the power 4. Then it becomes positive. Then you've got 3 times 12, which is plus 3 times 12, which is 36. I think there's a question somewhere there. Let's just hold on. I saw a question. Okay, the question is about this 28. I think there's a mistake there. That's a misprint, isn't it? We forgot to put another minus sign this way vertically, because they're too much. Remember the story. When you make a minus sign meet like that. This one kicks this one here, then it goes this way, then this jumps over like that. So that's why it's like this. Altogether. That's a mechanical way of trying to remember this thing. Mechanical and beautiful. Altogether. Okay. So now we add these numbers. Let's check what we get there. Are you in grade 1? I used to add like this: 36, 1, 5, 28. Just check that. Is even 36 is wrong. Even 36 is wrong. Okay, what is it? Y minus 15. These are 3 negative signs here. They give us negative. And the entry at 1, 2 there is negative. So we've got 2 negative signs, then that will be 15, isn't it? Okay. So what do we have here? We've got 3 plus 1, 4 plus 1, 5 tenths, which is 50. Oh, that's right. Okay. Then here we've got 10, 6 and that, which is 14. Is that right? And then we've got 5 units there. This is 9. This is what? 7. Did you see? I didn't carry anything. Did you see? I didn't carry anything. You think of carrying things and carrying things. 7, 9. Are you not happy about this? It looks beautiful. Altogether, this is yet another approach of calculating determinants. Altogether. Yeah, okay. So now what I'm going to do, I'm going to pause a bit and try to listen to your queries, to your frustrations, and maybe clarifications. Altogether. Okay, let's see your clarifications or your queries. Okay, I think I'll leave it there. I'll leave it there for you to convince yourself to do exactly the same kind of calculation using either a row or any column of your choice, and you see that you get the same number. Then you convince yourself that anything I want to calculate the determinant of 3 by 3, I can do this. And I hope you can try to look at this and see how can you adapt it to a 4 by 4. Altogether. So you see you can go from 4 by 4 to 3 by 3 to 2 by 2 and end up with a determinant like that. Then from 4 by 4 you can upgrade to 5 by 5. Until maybe you cannot do it manually. Maybe you need a kind of to think of how you can write a program on a computer to do it for you. Altogether. Okay. But you can do it only when you understand. Is that right? Right. So now having this kind of a thing now, what I want to do, I want you to recall, to go back to the problem which you had before, and just try to see that you can use this again to calculate determinants. With this exercise, 2x plus 3y equals to minus 1, and the 4x plus 5y equals to minus 3. I think here, what we did actually, I want to show to you something I want to do this 2, 3, 4. Is it a 5 or 6 here? 5. And this is A. Then let's leave it there. Let's have minus for this matrix A11. A11 for this matrix. A11 for this matrix. What will be that be? Drop this one, drop that one. The minus is 5. A1, 2. Drop this, drop that. The minor is 4. A21. What's this now? A21. Drop this, the answer is 3. A22. The answer is 2. Let's now calculate the determinant of that. What do you do? You take this minor, the sign which will be positive, isn't it? And multiply by that 2. You get 2 times 5. Isn't it? Plus. Isn't it? Then you take this minor. You take that into 3. You take this minor and the sign there, which will be negative because there's power minus 3, isn't it? So minus 1 for that sign, and then multiply by that 4. Then you get this as 10 minus 12 equals to minus 2. Didn't that look beautiful? It looks beautiful, huh? So what we were doing before is actually exactly what we're doing now. What I'm trying to do is that I'm trying to make you see the link between what we're doing now and that we're not doing anything different. It's exactly the same thing. All together, guys. So now, if I do this, C 1 1, and go do this, and say minus 1 to the power 1 plus 1 multiplied by 5. What am I going to get here? I'm going to get 5. 5. Then I say C 1 2 and do this minus 1 to the power 1 plus 2 times 4. I'm going to get minus 4. Do you see that? And then I go C1, what? C21. Then I go minus 1, 2 plus 1, multiply by 3. Then I get what? What do I get there? Minus 3. Then I get here C 2 2. The sign is positive. I'm not going to count it. Then multiply by what? The entry. What is the entry? It's 2. Is that right? Then do this. I make a matrix which I call C, and then I do this. 5 minus 4 minus 3 minus what? What is it? 2. Then I do this. I call this a matrix of cofactors. How do it? Matrix of cofactors. Then I take CT. What is CT? CT is the transpose. What do you mean by transpose? Rows change to columns. All together. So the first row is going to be the first column. So I write here 5 minus 4. All together. Then minus 3, what's that? 2. If you compare this with the original matrix there, it looks like 3 here is changed its position. After transposing 3, I'm not talking about the sign of 3. 3 goes back and the 4 comes back to where it was. Do you see that? Do you see that? But now if you look at this matrix, this is what was inside the bracket here when you're calculating the inverse. 5 minus 3, minus 4, 2. And to be inverse, we lacked one thing. What did you do? We had to multiply by 1 over determinant minus 1 over the determinant. Determinant is minus 2, but I choose to put minus 1 there. And that is an inverse. Now listen to what I'm trying to say here. What is the big message from here? The big message I'm telling you that the process of calculating an inverse of a matrix now, it cannot be done easily like we did it. We just turn around this and blah, 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 blah. Altogether, what is it going to do? It's going to consist in calculating cofactors, using cofactors and minus there, isn't it? Once you have done cofactors, you make a matrix of cofactors. Once you have done matrix of cofactors, here it is. You transpose it. So the first thing is to get initial step here. Get cofactors. From cofactors, second step here, you get cofactor matrix. Now using cofactors, you make cofactor matrix. Then after cofactor matrix, second there, I'm counting initial, step 1, step 2. Transpose the cofactor matrix. And this transpose of cofactor matrix has got a special name. I'll write it down here. This transpose of the cofactor matrix has got a special name. It's called the adjoint of A. That's how it's abbreviated. The way it is written this way, adjoint. This is an N, sorry. Adjoint. That's an adjoint of A. It looks like now the determinant of the inverse of any matrix is going to be 1 over the determinant of the matrix multiplied by, what is this? Is the adjoint of the matrix. And as I'm talking here, last week when we were talking about the inverse of a 2 by 2, we were talking about the inverse of 2 by 2. Now here, I'm talking about an inverse of any square matrix whose determinant A must be what? Must be what? Must not be equals to 0. Otherwise, if it's equal to 0, this is not going to be defined. Then the whole inverse is going to be defined. Because the commandment says, the very, very first commandment says, thou shalt not divide by 0. How do you get that? So let's summarize what we've learned today. We've learned how to calculate determinants of 3 by 3. All together. We've learned minus and cofactors, and we've seen how cofactors can give us determinants also. And then now we're relating this to what we did last week. We're getting to the conclusion that a determinant of any matrix, an inverse of any matrix whose determinant equal to 0 is going to be 1 over the determinant multiplied by the adjoint of that matrix. How do you get that? So what you've got to do now, you've got to try to go and soak yourself in this kind of way. How do you soak yourself? By doing it. Are we there? Otherwise, thank you for listening.